In the next couple of examples, we'll look at some IV medication orders. Example number 1. We're given an order for lidocaine, 2 grams IV and 500 milliliters of D5W at a rate of 2 milligrams per minute via infusion pump. You're asked to prepare and hang the 500 milliliter bag that has the lidocaine added to it. We're asked to then regulate the flow rate so that the patient receives the appropriate infusion rate of 2 milligrams every minute. The pump is calibrated to deliver in tenths of a milliliter per hour. Determine the flow rate. So our goal in this case, again, is to identify what is the appropriate milliliters per hour as our desired units. We start with the infusion rate. In this case, we're given an expected infusion rate of 2 milligrams per minute. Of course, the flow rate is needed in per hour. So the first conversion that we can do is the minutes to hour. So 60 minutes for every 1 hour will tell us how many milligrams per hour is necessary. The proportion of this that we will actually infuse is going to be based on the information here. The lidocaine is in 2 grams for every 500 milliliters. So the proportion there that we'll need for the stock is in the ratio 500 milliliters for every 2 grams. If we take a look at our units, here we'll end up with, of course, our time component, removing the minutes, leaving me with hours. However, we still have the issue that our units for the mass, milligram and gram, still show up. So the last sort of conversion that we'll need here is from milligrams to grams. So we can introduce the component here of 1 gram is equivalent to 1,000 milligrams. After we cross out the remaining milligram and gram components here, that leaves us with milliliters per hour as desired. Based on our computation, if we do the numbers, we end up here with a rate of 30 milliliters per hour for our solution. Example number 2. Here we're given an order to administer 250 milliliters of IV solution with 225 milligrams of medication to infuse at a rate of 3 micrograms per kilogram per minute via infusion pump for a person that weighs 110 pounds. And again, we're asked to determine the flow rate for the IV pump, which is calibrated to whole numbers of milliliter per hour. So just as before, we're interested in identifying the number of milliliters per hour being infused. We start with the patient weight. We know the patient weight is 110 pounds and can be converted easily to kilograms using the following ratio. The next component is the dosage. The dosage is given here to us in terms of micrograms per kilogram minute. So the given ratio here needs some conversion factors. Of course, we want, instead of minutes, we prefer hours, so we can introduce 60 minutes per 1 hour. We'll also need to convert from micrograms to milligrams, so we can also include 1 milligram for every 1,000 micrograms. Lastly, we need to introduce our stock component. So again, let me make some space here. We want to end up with milliliters per hour. The last component, as I said, is the stock, which we're given here at the top. So for every 250 milliliters of solution, we have 225 milligrams of medication. The appropriate ratio here is going to be put milliliters in the numerator and our micrograms in the denominator. Milligrams. So looking at the units here, now we can see that the cancellations that we want will occur such that we get the units that we desire. I'm left with milliliters per hour, and based on our computation here, if we use our calculator, we should end up here with 10 milliliters per hour for the final flow rate for the given pump.